Hello, this is Lazarus at telecomTech, where telecom and networking technologies are simply explained. Today we'll be simply explaining Border Gateway Protocol, or BGP. So what is BGP? Well, it's the main and actually the only routing protocol that is deployed on the internet. Now, unlike other routing protocols such as EIGRP or OSPF that you may be familiar with, BGP does not use a metric to determine the best path. So for BGP, the most important thing isn't the shortest path to the destination. It relies on a whole series of other parameters to determine the best path. Now, before we get to that, to understand a little bit more about BGP, we'll need to take a look at the structure of the internet. Now, the internet is huge, so BGP must be extremely scalable. That means that it must be able to handle a huge number of routes that exist within this worldwide network. For this reason, BGP subdivides the internet into what are called autonomous systems, or ASs. Each AS is assigned a particular number, and it's considered to be an independent entity that is controlled and administered by a particular organization, such as an ISP or a large enterprise. Now, each AS contains tens, hundreds, and sometimes even thousands of BGP routers. And within each AS, we have the actual end devices that are served by the internet. That includes things like web servers, email servers, cloud services, and any other service that you may be using over the internet. Also included within ASs are all the hosts, the end devices, the end users that are connected to the worldwide internet. For example, the device that you're watching this video on actually belongs to a particular AS, probably the one that is provisioned by your ISP or your corporate or enterprise network. Now, what BGP does is it determines the route to a particular destination via the autonomous systems that must be traversed to get there. In other words, for a particular destination, it will create what is known as an AS path. This is essentially a list of AS numbers through which a packet must be routed to get to the destination network. So looking at this diagram, let's say that the host at the top with an IP address of 20.20.20.10 wants to reach the web server at the IP address 30.30.30.10. The packet will reach the first BGP router found within AS100, and it will look up how to get to the destination. Now, each BGP router maintains what is known as a BGP table. If we take a look at the entry in the BGP table of our first BGP router, we see that we have a path to the 30.30.30.0/24 network. Now, this is the network to which our web server belongs. And the path that is indicated to reach this destination network is 100, 150, 140. So this is essentially a list of ASs that must be traversed to reach our destination. Now, there's more information included in that BGP table, which we won't talk about right now. But what's important is that the AS path is indicated here. Now, what does that path look like physically on the network from end to end? Well, it's a path that goes through ASs 100, 150, and 140. And that path indicates how to get to the destination AS. Even though the line in the diagram seems to go through particular routers within ASs, typically BGP will not be responsible for how routing takes place within an AS. That task falls to an interior gateway protocol, or IGP. These are the more conventional routing protocols we know about, which include OSPF, ISIS, and EIGRP. BGP, on the contrary, is responsible for determining the AS path to the destination. BGP thus delivers a higher level of routing information than IGPs, and this is primarily the reason why BGP is so scalable and thus ideal for the internet. Now, this is also why BGP is known as a path vector routing protocol, where path is the key word here. Now let me just say a couple more things before I end off. How does BGP determine this best path? Well, as I hinted at the beginning of the video, the best path over the internet is rarely the shortest path. Routing on the internet must take into account various other criteria, such as compliance with agreements between entities administrating particular ASs, or the cost of routing traffic through one neighboring AS over another, or even geographical considerations, where we may want to physically route traffic through the infrastructure of one country and not another. Now, because of all these extra criteria that must be considered, BGP must be much more granular in its configuration and operation than more conventional routing protocols. So let's take a look at our routing scenario again, but this time, let's say that we've configured BGP to take a different route based on other criteria that we want to use. Let's say that it's actually cheaper for the ISP that owns AS100 to route its traffic via AS190. In that case, we would have a different AS path indicated in the BGP table, specifically 100, 190, 160, 140. This is an equally valid AS path to our destination and may be chosen based on all of these other criteria that we may want to take into account. Now, until now, I've been calling these things criteria, but in the language of BGP, these criteria are called BGP attributes. Now, these simple examples are just beginning to showcase the level of granularity of routing and decision making that can be achieved using BGP. And this is essentially done by employing and tweaking these BGP attributes. Now, we'll be talking more about BGP attributes in detail in another video. So in summary, BGP is a path vector routing protocol, which is used on the internet. It's vastly scalable and determines the best path to the destination using a series of tweakable attributes. The best path is recorded in the BGP table as a list of autonomous systems that must be traversed to get to the destination network. And finally, BGP is typically responsible for routing from AS to AS, while IGPs are used to take care of routing within each individual AS. Well, I hope you found this video useful, and if you have, please make sure to click the thumbs up button. If you'd like me to address other related topics, feel free to let me know in the comments, and please subscribe to get updates to newly published videos. I'm Lazarus at telecomTech. I hope this has been helpful for you, and I'd like to thank you for watching.